All right, everybody, welcome to our ACE venture with PCL, coming to you from Los Angeles and the UCLA campus. And here are your PCL panel, and I'm going to turn it over to Mark today to get started. Thanks, Mark.
Well, thank you, Paulette. And first, we wanted to thank the ACE program for having us here and say how excited we are to share the content that we've put together for you today. We wish we could meet each of you in person, but are fortunate that we're able to use this platform to reach so many of you virtually. Before we explain the plan for today's presentation, we first want to introduce to you our panelists. So first, my name is Mark Schneider. I've been in the construction industry now with PCL for almost 15 years, where I'm now a construction manager. I went to college in Pennsylvania at a school called Lehigh University, where I studied civil engineering. After I graduated, I moved to California from the East Coast to start my career with PCL. So far through my career with PCL, I've worked on many project types, including a performing arts high school in Los Angeles, multiple parking structures, historic and high-rise renovation projects, and multiple student housing projects at UCLA. When I was in college, I wasn't quite sure, what path I wanted to take upon graduating. And most of my classmates in civil engineering field took a path in some sort of design-related field. I chose to go into construction, and I'm really happy I did today. Currently, I am involved with overseeing a large student housing project at UCLA, and that is what our presentation today will be based around. So next, Christoph is going to introduce himself.
Thanks, Mark. So my name is Christoph Buer. I've been working with PCL for just under 23 years, so most of my adult life. My path to PCL management, however, my road is a little different than you'll hear from the rest of the panel's members. I didn't take the college or university route that many of you may think you need to do. So I'll go into a little bit of that. I grew up in a small town in Manitoba, Canada called Birtle. After high school and 1 year at university, and a couple of years of working as a carpenter, I moved to Winnipeg, Manitoba to start my career with PCL. This January, however, I was relocated to work with PCL in California on the project here at UCLA. So a little of my education. After completing high school, I went on to university for a year, like I said, and that wasn't for me. So I took some time off to travel. And then after my travel, I started working as a carpenter's helper with my brother. After about 6 months or so, I started an apprenticeship with a small residential builder. And halfway through that apprenticeship, I was hired on with PCL as a carpenter. So I've worked through all levels of carpentry with PCL, from apprentice to journeyman carpenter to a lead hand to a foreman to a superintendent. And now my position is senior superintendent at Southwest Apartments at UCLA. So I've worked in a total of 4 different districts with PCL right across Canada. And now I'm in my first district in California at CAB. So I'm excited for all of you to hear about our opportunities and hear about us, our paths, and about our awesome project. So here's Jesus to tell a little bit of himself.
Thank you, Christoph. Good afternoon, everyone. My name is Jesus Van Rostro. I'm a project engineer with PCL Construction. I have been with PCL for a little bit over 2 years and 5 years in the construction industry. I'm currently working at the UCLA Southwest Campus Apartment, the project in which we're going to be talking a little bit about today. I graduated from Cal Poly Pomona with a degree in engineering technology, essentially construction management. And thank you for letting us share a little bit of our company and our project. With that being said, I would like to pass it on to Ali.
Thanks, Jesus. Hi, everyone. My name is Ali Forster. I am currently a field engineer with PCL in Los Angeles at the UCLA Southwest Campus Apartments project. I actually graduated from Cal Poly San Luis Obispo with a degree in construction management, and I've now been with PCL just over 1.5 years, where on the project we're going to be giving you some more information on today. I focus most of my efforts and all of my learning on self-perform concrete. I'm going to pass it over to Fawn now to give her introduction.
Hi, I'm Fawn Radmanich. I'm the Marketing and Communication Manager for PCL's California Buildings District. I'm the only one on this call not currently working on the UCLA Southwest project. However, I was an early member of the team as I helped to win the job that the team is now working on. I've been in the architecture, engineering, and construction industry for 20 years, the last 7 of which have been with PCL. During that time, much like Mark has done a variety of different kinds of projects, I have helped to win a variety of different kinds of projects. I got into this mostly by falling in. I kind of tripped and fell into this role. But I actually have a degree in communications from St. Mary's College of California. And I have a certification as a marketer. I am a certified professional services marketer. And so I actually am qualified to do this work. And so I'm going to transition to talking a little bit about PCL, since I'm the marketer in the group. So give me just a quick second while we share screen. And here we go. So PCL is a group of independent construction companies that carry out works across the United States, Canada, the Caribbean, and Australia. We were actually founded in Canada, which would be one of the reasons why we're the #1 contractor there. Our operations cover civil infrastructure, heavy industrial, but what we're here to talk to you about is our buildings market. And these markets are all supported by our presence in more than 30 major centers. PCL has an annual construction volume of more than $7 billion. And that makes us one of the largest contractors in North America, both in Canada and in the United States. And then we are also employee owners. And as employee owners, we focus on shaping the future of construction through exceptional relationships and a deep commitment to the success of our clients, colleagues, and communities. We have a long history of proven performance, helping customers of all sizes solve unique and complex challenges. Here you can see a small selection of some of PCL's iconic projects. You might recognize a few. One of my favorites is the Wizarding World of Harry Potter for Universal Studios. And PCL actually built both the Los Angeles location and the Orlando location. And in Orlando, we've built all 3 of the pieces of that particular world. We also built the Vancouver Convention Center, which has been certified as a LEED Platinum project twice. And the Mall of America, while you might not have been there, is still the largest mall in the US, and that was built by PCL many years ago. And then right here in Los Angeles, where we all are, we built Staples Center, which is the home to the LA Kings and the LA Lakers. And continuing along the line of Los Angeles, we have combined our broad expertise and drive and determination and a willingness to take on the most difficult projects to be able to work on some amazing and quite iconic projects here in LA. So in addition to Staples Center and the Wizarding World of Harry Potter, we've also been performing all of the stadium renovations at Dodger Stadium for the last few seasons, off seasons since 2014. The largest and most significant was completed in April of this year, which revised their center field. And today we'll be talking about one of our many projects at UCLA. We've done quite a few projects out there. So now I'd like to turn it over to Mark to talk about that.
Thank you, Fawn. So now we're going to get into the meat of our presentation. So today's presentation involves around a project that we're currently building at the UCLA campus. So it's a $300 million student housing project that we started construction a little over a year ago. So the project consists of 3 buildings of 8 and 9 stories and will include almost 360 apartment units, housing just over 2,200 students. So the building structure consists of what we call cast in place concrete. The interior is metal frame walls, and the exterior is framing and plaster. In today's presentation, again, we're excited to share with you 4 videos that we have put together to show construction taking place and the high level of coordination that's required on a daily basis. So after each video, we're going to set aside about 5 minutes to answer questions. So please feel free to type your questions in the Q&A section, and we'll answer as many questions as possible. You should see a Q&A button at the bottom of your Zoom screen. So please make sure you ask questions. So in this first video, we're going to show a time lapse of all construction at the UCLA project from start to where we are today. And you'll see some explanation of what is happening in each phase. So Fawn, go ahead and play the video. The activities that we start with on a new ground up structure are what we call earthwork and shoring. In these first clips, you will see the earthwork and grading activities. You can see large equipment, including front-end loaders and excavators. The equipment is what we use to move dirt around, excavate, and compact the existing soils to the elevations that the drawings call for prior to beginning the building foundations. Once we have the site to the elevations needed, we begin installing deep utilities. Here you can see green pipe laying on the ground that is for future sewer and storm drain lines. The deep utilities are put in early, prior to foundations being started. Here you will see what looks like a darker gray flat surface that is put through the middle of the site. This is crushed rock material that we place to make it easier to move large equipment through the site without digging up dirt. This also helps keep the site clean and less muddy when it rains. In these next phases, you will start to see more material being stored around the site as we begin to enter into the structure phase of the project. Here we are beginning foundations, followed by concrete walls and concrete columns, or what we call vertical work. Foundations are dug with a backhoe, reinforcing steel is placed inside, and then are filled with concrete. These foundations are what support the weight of the buildings we are building above, and thus distributed down through the walls and columns. Digging foundations with a backhoe requires a high level of skill and detail that can be seen in the middle of the project site. You'll start to see more crane activity on site now, first with mobile cranes that are able to move around the project site. These cranes are used to place rebar and to set concrete formwork. Formwork is what makes the shape of our walls and columns, and is what the concrete is placed inside of. Once the concrete cures or dries, the formwork can be removed and reused in most cases. This is what we call cycling our formwork. As the project progresses and installs foundations, we begin to get ready for our tower cranes. The project installed multiple tower cranes that each have to be thoughtfully planned out to location, the reachable radius, and the capacity needed that they can lift. Each crane requires a foundation to be set and its own crane to be built with. This is what the large yellow crane you see in the middle of the site is. The foundation stage is often one of the more difficult parts of the project for many reasons. First, space starts to become much more limited. It is the beginning of the project, and crews are just getting to know each other and to work with each other. Work is often different throughout and requires a good understanding of details and drawings. Foundation work requires moving and hauling around a lot of dirt, which requires a high level of planning for where it will go so that it's not in the way of other parts of the project. If work is done in the winter, rain can have a large impact due to water and mud. If work is happening in a colder climate, you're also dealing with harsh winter conditions, including snow. As more cranes are installed, the project has the ability to move things around more quickly, and more walls and columns begin to take shape. The project then begins to move into the elevated deck stage. You will see in these sequences, each building begins to get taller and taller. The decks are built with vertical shoring posts that support plywood. Rebar is placed on top of the plywood to reinforce the concrete. Once all rebar is placed, we then place concrete on top of the plywood and shoring. This is what creates the concrete deck. Each deck is required to cure or set for 14 days. Then the plywood and shoring can be removed and cycled above to make the next deck. It took the project about 1 year to get from the foundation stage to the roof, which was 10 floors. As the buildings come close to topping out with concrete, you can see some other work start to take place. Scaffold begins to go up around the exteriors to begin installing the exterior systems that will eventually be a plaster finish. On the inside of the buildings, something you can't necessarily see here, we have interior framing, electrical, plumbing, and mechanical systems beginning to take shape. Today, we are just about 50% complete and are transitioning to getting the building's roofs in place and the exteriors completed to a stage of what we call being dried in. We will be complete with construction in September of 2022. Okay, so that's our first video. I think we do have one question in the chat that we can address. So the question was, how big of a concern is dust, sound, and other things that affect the surrounding areas? Christoph, do you want to chime in on this one too? But so we definitely have to think a lot about dust and sound, especially depending on where we are working and what neighborhood we are working in. At UCLA, we're on an active college campus. So there's student dorms around us, and there's neighbors that are certainly sensitive to the sound that we're making. So we can't have any noise on the job site before 7 a.m. And no noise after 6 p.m. But we also try to limit some of the noisy activities during certain times of the day if there's exams going on at certain time periods. We also use water to keep the dust down. We've got water trucks, and then we use water hoses to spray around the job site, so we're not having large dust accumulations with our neighbors. Anything you want to add there, Christoph or Ali?
Yeah, I think one thing we can add to that, Mark, is not only do we use water to keep the dust down, and that's a constant battle in a climate like California, we also have what we call rumble mats. So at each entrance of the job sites, we have two main gates. We have a series of rumble mats. So as the trucks, delivery trucks and dump trucks that come in and out of the gate on wetter days, they get real dirty underneath, and the tires get full of crud and mud. And in California, you have to be really careful about retaining all of your material on site, and not letting that material, escape or be traveled down the road and cause havoc for your neighbors. So we have rumble mats everywhere, and that really does a good job in keeping the streets clear and clean. And with that gentleman that's always there at the gate, or the personnel's at the gate with the water hose, he's continuously washing off these rumble mats that are made from steel, and he keeps them clean.
So we actually have a couple of other questions that have come in as well. We have people putting questions in both chat and questions, which is fine. And so one of the questions that came in is, what happens if a disaster like an earthquake destroys part of the project?
Sure, I think that's a great question. So we have a plan if there is any sort of disaster, that we have a plan to evacuate the job site. So what we use is 3 blasts of a horn if there is a disaster like an earthquake, so that we can get everybody out of the building. And then we do a head count. All of our foremen know how many people, and all of our foremen and our superintendents know how many people are on the job site. So we count to make sure we've got everybody accounted for once they're in those, what we call muster points, or the evacuation zones.
And then the next question we have is, can you talk about the metal work that goes into the buildings?
So there's lots of different, I guess, types of metal work that we might maybe is being referred to. So we've got steel. So there's reinforcing steel that gets placed into the concrete that strengthens the concrete. Concrete is very strong in compression, but it's not as strong in tension. So the rebar is installed to add tensile strength to the concrete. There's also steel, structural steel that can be used, and we've got other different types of metals like metal stairs and sheet metal that cover all different types of scopes that go into a building.
So here's one. How do you put cranes in a construction site?
Ooh, that's a good one for Christoph.
All right, for sure. So how do you put cranes at a construction site? So I guess there's many different types of cranes, and to sum it up, you have to look at your job and your tasks that you have to carry out over the course of the entire project. So as Mark explained in the video, those are mobile cranes. So those cranes can drive themselves on and off the job site. So they're hydraulic or they're conventional, depending on the size is kind of tells you how easy it is to transport these cranes. But you can actually take a crane that is a 500-ton conventional that used to take a week to set up on site. You can drive a hydraulic crane, which is new technology, onto site and set it up in about a day. So those are the kind of mobile cranes. And then we'll get into the tower cranes. You're going to see a tower crane come down. And just to explain a little bit about a tower crane is those tower cranes come on several trucks, semis, and they're put together by the use of one of those assist cranes or transportable, the cranes that can transport themselves. So we'll show you exactly how that crane comes down, and then you can just kind of pretend you're watching the video the opposite way, and that's how they go up. So a little more to the tower cranes, but that's how a crane gets on the site.
So we have a few more questions, and then we might want to move to our next video. The next question is, what are your biggest concerns for California weather? And as you were working on this building, did you think about wildfires and change the infrastructure due to the current stage of California's climate?
Yeah, that's another very good question. So weather that we're concerned with on the job site, and especially in California. So we have to plan for weather during construction. So we're always looking ahead and seeing when it's going to rain or how the wind is going to affect us. Our tower cranes can operate in high winds, and we're highly dependent on using the tower cranes in our daily construction. So if there are high winds, we have to think about that and plan for that. And then if there's rain in the forecast, we have to think about how that's going to affect work that we're currently putting in place, especially if we're in the ground and foundations and have a lot of dirt open. That can create mud and may require us to pump out foundations with water. And we can't pour concrete on the ground if the ground's not compacted. So we'd have to dry out that earth and figure out how to get it dry, and then we can move forward with pouring those foundations. Related to wildfires, where we're at UCLA, we don't see as much wildfires as some other parts of California does. But there certainly is a lot that goes into design of buildings and fire ratings and determining what the fire ratings are in each different type of building, and making sure that they're up to California codes and what UCLA, especially being on UCLA campus, what they require for fire separations.
Okay, so we do have more questions, but I'm going to ask just one more and then hold the others until a little bit later in the presentation. So the next question is transporting material onto and off of the site challenging, particularly in a packed place like the UCLA campus, as far as, and this is in particular to closure and detours?
Christoph, you want to take that one?
Sure. So you're right. So we have a pretty jam-packed site. The start of the video showed a nice wide open site, and then towards the end of the video, as you've noticed, the buildings take up 80% of the landscape. So to get these big trucks in and out, you physically have to go and walk your neighborhood before the job starts and start making your rules and regulations for all your contractors and your trades to know how big of a truck they can bring in. Sometimes you build roads to get to your job sites. Sometimes you change the infrastructure. You put a bridge in place, depending on where you are and what the project you're building. Sometimes you just need to get there. So there's a lot of different options and a lot of different reasons why you would change your logistics of how you get the site. And your planning, one part of your question, I think, is how do you plan out the job site for deliveries? Well, every day we're planning. It doesn't stop. It changes. And you got to schedule each and every trade to bring in what they need to keep up with schedule. So the quicker the schedule, the more product you have coming very regularly. And everybody wants to bring in their product first thing in the morning, the day of. So you've got to schedule those deliveries throughout the day, so you have room at each gate and room at each entranceway, and you have a crane to unload that material as well. So lots of different moving parts there to make sure your deliveries are in on time and when you need it. And it's important to not let your trade partners bring too much material as well. So if you don't need anything for a week, you don't bring it to site, and that's always a challenge. So you got to remember that.
Thanks, Christoph. So I think now we'll move on to our next video. I know there's another question, and we'll try to get to that one at the end. So Ali is going to introduce the next video that we have for you.
Thanks, Mark. So as Mark mentioned previously in the presentation, at UCLA Southwest, the primary scope of work that has been going on for the last year and a half now is cast in place concrete. These structures are from the ground up about 10 stories tall each, and the physical material that builds them up is concrete. And just as the questions you guys were asking regarding, how do you bring trucks and deliveries into the job site? Well, our concrete comes in trucks too, and all the material that goes into these pours come on trucks. So coordinating all this material onto the job site prior to the concrete pour and then scheduling the trucks for the pour is everything that goes into a successful concrete pour. So this video we're going to lead you in with kind of gives you a day in the life of what it's like to live on the Southwest Campus Apartments job site. Let's jump on site to a day in the life of a concrete deck pour at UCLA Southwest. Job sites are clearly pretty busy places, so there's a lot of different things that need to be coordinated in order to make a concrete pour successful. All the people you see here will help plan the things we're just about to talk about. Multiple team members are involved in any successful concrete pour. But on this job, prior to placing any concrete, PCL management will use checklists developed in-house to verify that all the steps have been taken to ensure a safe and accurate concrete pour takes place. Everything you see below gets installed and reviewed by the PCL management. However, it is continuously inspected and eventually signed off by a certified inspector from the university. Just like baking a cake, there's a lot of different ingredients that really go into a concrete pour. We're not just one big building full of gray stuff. There's a lot of different parts and pieces to this building, what we may call the life of the building. So let's just point out a few items. In the concrete pour, we have what's called reinforcing steel, shortened to rebar, on the job site. This is what you could think of as the bones of any concrete slab, sidewalk, wall, anything you might see in a concrete building, and it gives the concrete strength and holds it together after the concrete's hardened. As I mentioned, some other ingredients are the things that give the building life. Maybe that's water, maybe that's power, whatever you might think, we have to think about that as we pour this concrete. So some items we'd like to point out would be different mechanical or electrical pieces of equipment. You see some squares in the deck. These are what we call blockouts. We'll have different pieces of mechanical equipment or vents running up through these decks so that as the equipment is brought into the building, we can successfully give air conditioning, heating, ventilation to the entire structure. For electrical, you see some things that look kind of like pipes in the deck, but they're actually called conduits. These are set in the deck And eventually, electricians will come after the concrete is poured and run their wire in through these little snakes through the deck and pull this wire to an electrical outlet, maybe a light, some different type of fixtures you might expect to see in any bedroom or kitchen in your house. And specifically on this pour, this is a specialty pour. It's actually the very top level of this building. And on a big commercial structure like this, roof equipment often has pieces that they need to go on after the fact. Some embedded elements, which you see right here, are going to be set in place in the concrete for future equipment to be welded on by a certified welder in the field. This will help give sturdy connection to the heavy equipment that goes up on these roofs that really service the building as a whole. Vehicle routes for concrete trucks are coordinated with the job site team to guide the concrete trucks in and out of the job site in a timely manner. In order to keep the workers productive and the pour go well, we have trucks lined up outside the job site to always keep somebody busy. That spider-looking structure you might have caught in that last frame is called a concrete pump. This is the large piece of equipment that transports the concrete from the trucks you saw up to the deck. What we'll do initially is we'll clean out the pump like you see here, what's commonly called priming the pump on the job site, to ensure all the previous residue is cleaned out before we get the pour going. Once all the coordination and prep work is complete, the real action really happens. The lead concrete laborer will, as you see, take hold of the concrete pump and begin to maneuver the hose around the pour. He guides the concrete out of the pump in order to ensure it's being placed evenly across the slab. Our friend in the yellow hat that you see is carrying what's called a vibrator. This piece of equipment is dropped in and out of the concrete slab as the concrete's poured in order to ensure that the concrete cures and bonds correctly. And there he goes. He's falling right behind the pump man. The guy in the corner you see there is watering the deck kind of like you'd water your front lawn, but this is a key step in order to have the concrete retain moisture as it's being poured and ensure that it doesn't dry quicker than it's being poured in the field. On this particular day on the job site, the crew poured around 220 yards of concrete in just about 4 hours. Once enough concrete is poured, the finishers come into play. Just as their name really implies, the finishers are the ones that wrap up the pour by smoothing the concrete as it's poured into place. There's a few different tools that finishers will use, and the first one kind of starts with what you see here, screeds and shovels. Essentially, the finishers are evening out the thickness of the concrete as it's been poured in place and ensuring our friend with the hose in his hand didn't pour too much or too little in one specific area on the deck. It's important to communicate to the finishers how the deck is to be finished, to what thickness, what level of finish. There's a lot of different elements that come into play once the deck is poured, and the whole crew needs to be aware of what's in the slab to ensure everything can be used after the fact. Eventually, a vibratory screed is going to be used on this slab. You can see here that the crew member is using this piece of equipment on a larger surface area. It helps him more rapidly smooth out the concrete as it was poured. However, we got to keep in mind, once we get to this point, the concrete pour is not over. Finishers will eventually request to fly over what are called power trowels. As you see here, these are walking machines with a funny spinny thing on the bottom that essentially finishes the slab in circles and gives it the final finish required by the architect, the engineer, any designer that really wants to see what the building will look like after the fact. It's important, as I mentioned a little bit ago, that finishing is to the expectation needed for any future materials to connect to the concrete, or if it's bare concrete, that it looks presentable to the end user. In this case, that would be the management and maintenance staff at UCLA. At the end of the day, we have a complete concrete deck, as you see, but the work isn't done for any PCLer. What we do at this point in the day is we utilize new technology called laser scanning to really get a full view picture after the deck has been poured. Laser scanning has been a huge resource at UCLA Southwest in particular. It essentially has created photo images for the team to analyze the deck as it's been placed in the field and see how close it has reached to the design intention. So the different thicknesses, the different finish levels can all be reviewed by the team in order to, again, hopefully solve problems just like 3D modeling will help you.
So that was the conclusion of the second video. So thanks, Allie. Looks like we've got a few questions come in about that one.
So the first question is, how expensive is concrete compared to other building materials such as steel?
Yeah, so that's another great question. So the cost of steel tends to fluctuate a bit, but I would say overall steel tends to be a little more cost effective compared to concrete. But there's a lot more that goes into it. You know, what is the intent? What is the design intent of the building? Who are the end users? How long is the building planned to be used for? Is it a 75-year life? Is it 100? You know, how long does the owner plan to get use of this building? You know, different performance requirements such as fire ratings and sound ratings. You know, if it's a concrete building, it tends to get better sound performance than maybe a steel building with metal decks. So there's a lot that goes into determining what the right building material is, depending on who the owner is and how they're going to use the building.
Okay. So how many construction workers were involved in this project?
Christoph, you want to take that one? How many guys we have today?
Sure. So today on site, we have in the neighborhood of 365, give or take, you know, 5 or 6 workers. But that's what we have on site today. That's not what we had on site to do the foundations, to do the dig work, to do the demolition. Literally thousands of people have already gone through our gates and have been orientated by our safety staff to the state. And we're going to get probably another 1,000 of new workers on site by the end of the project. So there's a lot of people, a lot of different trades, and a lot of turnover that happens because you don't use the same trade all the way through. Like any project, you have steps, and as one step is complete, another step starts, and that's a whole nother group of people that have to be orientated and give their skills to the project. So, and one thing I want to someone else just asked a question. Mariah, you asked if construction is just for men. Well, in the panel, we can attest to you that no, construction is not just for men. It maybe used to be like that when the Hoover Dam was built, but nowadays there are many women on site, and they're extremely valuable to the project. And we couldn't do it without new female workers like yourself that obviously is interested in getting to construction. So, absolutely, construction is not just for men.
And if it's okay, I'd like to add to that a little bit. Our district, which is $1 billion of the $7 billion I mentioned earlier, is actually run by a woman. Her name is Kathy Orchiola. She's our vice president, and she is a true builder. She started in the field just like all of the folks that we're talking to here today, and she built herself and her career and is now leading a very successful district. And she's a wonderful leader, and she encourages more and more for us to bring more women in. So we are definitely doing that, and we are seeing just wonderful numbers of people coming in of the female persuasion, and not everything in construction is in the field. So I am a woman in construction, and there are many people who fulfill other roles as well. And we have lots of safety professionals. We have superintendents, that we span the full career spectrum. The next question, this question is for Allie. How do you think your degree has helped you? And do you sometimes find your talents and worth are overshadowed because you're not an engineer, even though you prove valuable?
So hi, Tori. I wish I could meet you in person. This is a great question. Coming from a construction management background, that word management sometimes throws people off as to what the degree really encompasses. And something to focus on if you grow an interest in the construction industry is your technical skills will grow as you enter a field position. So being a field engineer on specifically a huge self-performed concrete job, I've gained knowledge on technical building skills, logistics on the job site, and everything related to the actual building itself while being in the field. And in school at the same time, that word management really helps with the perspective that PCL is on the other half of this job. We're working as a general contractor on this project as well, where we're managing multiple different trades and their work in place to ensure that they get the building built in time for the students at UCLA. And part of that is we're not performing any of the engineering basis. It's just the responsibility as a contractor to really understand the intent for that building design and be able to hold those conversations and solve those problems with the design professionals. So as a construction management student or alumni from Cal Poly, I think I've served well in correspondences with architects, with engineers, and specifically the owner here at UCLA, because I have a little bit of background in how the building is built, and I understand at what cost and what time frame we need that delivered. So you can really tailor your perspective as to who you're speaking to when you have that construction management background. Hopefully that answered your question.
Yeah, so I think we at this point need to move on to the next video. So we've got a third video here that Christoph is going to introduce.
Thanks, Mark. All right, so as we talked a little bit about cranes already, we're going to show you a crane dismantle. So on our project, we have 4 large cranes. On every project, small or large, you need cranes to move around material efficiently and most importantly, safely. So in this video, you're going to see what we call a top-down tower dismantle. So this crane that we're going to top-down dismantle is called a hammerhead crane. It is only about 175 feet high. Therefore, since it's not an extremely high crane, we are able to take the crane down with an assist crane. So we can do that, remove the entire crane with an assist crane like you saw in the previous video, the big yellow one in the middle of the site. So other dismantles, I'll just tell you about them real quick. With the assist crane not being high enough, you have to use what we call a tower bracket. So they're installed on the side of the tower, and then each piece of the tower is removed as the rest of the tower is being supported by the bracket and lowered piece by piece. So it takes a little longer, but it's sometimes your only option when you have no room or it's too high. So again, here you're going to see a top-down dismantle with an assist crane. So crane dismantle. So on this crane dismantle, we are working on a top-down dismantle. Other dismantles are when you install a bracket on the side of the crane and you remove each tower piece individually, which you'll see later in the film. So the day prior is a setup day. We set up, we clear the area, we tour the site, we ensure the team is safe and they're ready. The setup of the assist crane can take 1 to 2 days for a hydraulic crane, which you see here in the video, and other types of cranes can take up to a week like a conventional. So on this day, we also remove some of the accessories of the crane, the cameras, utility power to the crane cab, lights on the boom, jib, or the tower. The removal of the hoist cable is done on the previous day, and the cable hook. The first step in removing the tower crane are the counterweights. Removal of the counterweights that sit on the counter jib in a vertical position behind the crane. These weights allow the crane to be balanced when lifting large objects. The second step is removal of the boom and the jib. There are 4 to 5 pieces of the boom, and each piece is disconnected one at a time by removing pins and lifting them down to the ground. Once 2 pieces are removed from the jib, the trolley that runs back and forth to move the hook is rigged up and lowered to the ground. The remaining pieces of the boom are then lowered as the crane swings around
for access to the counter jib. So once the last piece of the jib is removed, the crane swings into the radius of the assist crane to hook up the counter jib. This is the portion that was holding the counterweights at the start of the video. So the third step is then disconnecting the power from the tower. Now that we're completed the swinging of the tower crane, we can disconnect the power and any other the connections that the cab has to the rest of the tower. Step 4, the cab and the turntable. The removal of the pins holding the cab and then we lift the cab vertically off the turntable. Removal of the back of the cab motor house and the rear platform that the operator uses to inspect the cable, the rear, and the motors. Once that is removed, the last piece of the cab assembly, called the turntable, that rotates the crane 360 degrees, is removed from the top of the tower. Step 5, the tower removal. Each tower piece is removed in a section of 3 towers. So on our crane, we have 3 pieces to remove, which is 9 sections of tower. A zoom boom or grade awl is used on the ground to help set these pieces down safely, one at a time. As they're set on the ground, they are dismantled, loaded on trucks, and removed off-site. Once all these pieces are removed, the assist crane can then be dismantled. This again takes 1 day for a hydraulic and up to a week for a conventional.
All right, great. Thanks, Christoph. So it looks like we've got some more questions flying in. There's one about Jesus, but I'll let him answer that one when he introduces the next video.
Yep. Do you want to take the next one? And
Sure. So the next question was, how long did it take for you to get to the position you are presently? Well, I think we've got quite a few different stories on this panel. So my current position, so I'm currently a construction manager. So what that means is that I'm one of the people overseeing this project. And it took me about, I guess, 12 years to get to that position. In our company, there's a few different paths. One is a project management path, and the 2 primary paths in operations are project management and superintendent. So it takes varying amount of time to get to different levels, but the general path for me was starting as a field engineer, then to a project engineer, and then a project manager, senior project manager, and construction manager. So to get to that point, it took me about 12 years personally. So I think the next question was, what are the big differences of working outside on a construction site, managing things, compared to working indoors designing buildings? So I think that question is, what is the difference between working for a contractor in construction and then working for a design consultant? And they certainly are different paths. When I was in college, I was considering going into design. I had a civil engineering background. And the 2 paths are quite different. Being in construction, I think you're really dealing with different people and personalities every day. We really have a team environment that's created on large projects like this, where we really all need to be functioning together to be successful. There certainly is probably that aspect in design too, but you're a little more out in the field and getting your your boots dirty working in construction, and you really get to touch things and see the work going in place. Anyone else want to add to that a little bit?
I could speak on that too. From a perspective working as a field engineer to a new field engineer on this PCL project, I've actually had not the engineering background, but I've had slight exposure of office-based style work that you might be thinking of versus actual field management work. So working inside the office is kind of like the behind the scenes of the whole production, right? We're producing that information, ensuring that it's coordinated between all the involved parties, and then most importantly, getting that information out to the builders and the crews in the field. And when you're on the field management side of things, you're expected to take that information and also understand it, because you are there as a facilitator to translate problems between people, solve problems with the engineers or other design consultants. So there's different factors, you know, on both sides you're solving problems, and some are a little bit more prepared problem solving, and in the field you are on the fly and figuring things out right there.
Thanks, Ellie. So I think we need to move on to the
Yep.
next video. We're running a little low on time. So Jesus, if you could just do a quick introduction, and then there was one question about what field you work in, and do you recommend that to others? So maybe you can just touch on that in your intro.
All right, sounds good. Thank you, Mark. All right, so start off my field where I work in. So I am a project engineer at the Southwest Campus Department. As mentioned earlier, I'm in charge of the structure of the project, being the PE for structures and drywall. When I say structures, I'm in charge of all the steel. I was helping out with the whole concrete scope of work. And then I also have a big role when it comes to technology. Would I recommend this? Yes, I would. It's amazing. Just to touch a little bit of the whole design versus construction management. And construction management, you're more well-rounded just because you get to touch everything, like Mark mentioned, rather than just being a specialist in, say, mechanical or electrical. But yeah, definitely recommend the role I have within PCL. Now, moving forward here, the final video we're going to be discussing is technology. So we're going to be sharing a little bit about the technology we have available to us in the construction industry and the way that PCL uses this technology as a tool to help us build. So we're going to be seeing the 3D model we use, which, as mentioned, uses as a tool. SiteScan is another software we use, which is a drone-based software. And the last thing we're going to be touching is another software that uses pictures to document the progress of the project using a 360 camera. So hopefully you enjoy this video.
The construction industry is traditionally based in a 2D sense. We're pen to paper, where we look at things in blueprints and then we go out into the field to build them. However, the industry has transitioned into a 3D world. We now use computer modeling to build the building on a computer screen, look at all the parts and pieces, and make sure everything fits together before we enter the construction site and build it on a real-life scale. When things get really large in the construction field, it gets difficult to solve problems on the job site on the fly. And computer modeling helps us look at the parts and pieces, analyze if something will become an issue, and solve the problem before it comes one.
Here you can see the foundations. The foundation is the first thing of the project, what starts everything out, and you go up through your structure. Specifically, our project was concrete, so it went all the way to the top of the building, pour by pour, and then came the drywall. At the same time, coming inside the building, you have all your mechanical, you have your plumbing, and as you close down the walls and everything in the exterior, as you see here, you have your windows and all other aspects. So what the model really does is help our field team understand how the project is built, and it's very beneficial in that way. Here you see a nice little walkway that would lead you to straight into the busway, so the students can gain access to public transportation very easy, as well as a nice little view of this arcade area for one of the buildings. Moving back into it, the site, you really see how the buildings are going to be looking as you walk through the courtyard area of the project. And then you really see the nice doors, windows as you go into one of the primary buildings of the project. So again, just the model itself is uh, a, a tool that we use out in the field just so we all know how everything's supposed to be built, and we can put a 3D view into the 2D plans that we worked out of. Here's a view of the interior side of one of the buildings and how it's going to look. There's a nice little area for the students. So the next part of our technology that we use at PCL and our project specifically is SiteScan. SiteScan is a program software that we use to get real-time information, real-time data from pictures taken from a drone 200, 300 feet above the ground. So what it does is we do a flight, couple of flights. It takes 200, 300 pictures, and then we input it into the software, and the software produces all this data that I'm about to share. One of these good examples of this data that we use is site logistics plans. A site logistics plan is basically a tool that we use on site to plan the work as we go through the weeks, the months, and we follow the schedule. Here you see how all the plan goes into effect. You have all the buildings identified. You have where the cranes are going to be, as you show in the middle of the site with those crane icons. You have the laydown area. You have the route to enter and exit the site, being gate 1 and gate 2. And then you also have your muster. So muster points, which essentially are, if there's an emergency, that's where you're supposed to meet. You have where the fire extinguishers are, so the fire marshal and the emergency department knows where everything's at. So this is one of the most critical tools that we have on site. And the awesome part about using SiteScan with this is that we can have a live photo of the site, and we overlay the logistics plan on top of it. So it's always changing as the project changes with the construction going on. Okay, here we have a comparison between 2 different flights, 2 different days. This is a good tool that we use just to see how the project changes from one day to another. As you can see here, these photos are about 3 weeks apart, and there's a lot of change in between them. So it really helps to grasp and understanding how fast the project moves. The next part of the tools that we can do with SiteScan is just having a 3D model. So this, you can see, is a live or updated mesh 3D model of the site, how it looks after we fly the drone. So this is kind of the data that we can export from it. In this, as the project continues, we can document the project and kind of give a good understanding of the status of the project and share it with the team, the owner, and whoever needs to see the project progress. The next thing on the list is the 3D mesh, which we can have a lot of live data, a lot of information that we can use to quality control, to checks in the computer that can be done in the field. For example, here you can see how I'm getting a square, which is giving me an area of the whole square that I created on the program. And then you can also get elevations, you can get distances, you can get point load, anything that you really need to do any quality checks. The next technology we're excited to share is a program called StructionSide. StructionSide is a software that we use where we document a lot of the day-to-day photographs, which are getting updated 3 times a week by our field team. As you can see here on the left, you have the actual as-built condition, or the way it looks in the field, versus what the model or what was planned. So as you can see, it's pretty accurate and pretty on point, the work in place versus what was planned. Moving forward in construction site. You can see here a plan view of the project. These are all predetermined locations where our team decided progress photos were going to be beneficial for the project. I'm going to move into another level here and show you how we use it for closing down walls. So a wall is a metal stud that's sandwiched by two pieces of drywall. So once we close those walls down, it's very hard to know what's inside unless we tear down that wall. With Structure Site, what we can do is take pictures prior to closing those walls to capture every component inside of the walls. So at a later date, if we ever have to or are in question of anything that's inside the wall, we can come back to the program, we can look at the photos and see exactly what was in there without having to tear down the wall and costing us a lot of money and headaches.
Thanks, Jesus. I know we're running a little bit long. Looks like we've got a few questions coming in, so we could try to answer those quickly. Looks like the first one is how long does it take to model a project like this into a 3D view? So this project is designed in 3D in a program called Revit. And that design process took about a year to get from start to completion. There's multiple iterations that go through design, but it certainly can, the model can certainly be built more quickly than that, but to get it to a point of that we're able to construct it, it took about a year.
The next question we have is, do you use software like SketchUp, Revit, or LexoCAD to design the 3D models?
Jesus, you want to take that?
Yeah, so with SiteScan, I'm assuming is where the question is coming from. So no, everything's done within the software SiteScan, which was developed by 3DR. All we do is we fly the drone, and then we import all those photos from the drone flight into the software, and it processes them, it stitches it together, and it creates all of these data, and we can export into those softwares you just mentioned. So yes, it can be exported into Revit, it can be exported into Navisworks, and can be exported into a lot of different softwares.
So the questions we have left are a few that we jumped over, but wanted to, it looks like Christoph answered one privately just to, or in typing. So if people want to look at that answering, but there was a question about how are you dealing with COVID and protecting people?
Yeah, so that's certainly a real thing that we're dealing with every day. So on our job sites, one thing, so what we're doing is we do temperature taking every morning. We have healthcare workers at our job site gates, and they take everybody's temperatures and ask a series of questions to make sure that no one's feeling any symptoms. We require 6-foot distancing, and we require everybody to have masks at all times. And then if we do see a positive case, then we do a detailed investigation to determine where that came from and make sure we're cleaning well so that we don't have any further spreading from that case.
And the last question that we moved past earlier is, does PCL use modular construction or prefab materials on any projects?
We do use modular construction. On this particular project, I think prefab is probably more what some trades are using. Our MEP, mechanical, electrical, and plumbing systems, they do a good amount of prefab in their facilities, and then they bring in that material to the job site on trucks and put it in place. We do have other projects that use some sort of modular building. We can build bathrooms complete together and ship them on trucks and put them in place. And that a lot of that requires early design contribution to be able to do that and incorporate it into the construction.
Okay. And we did have one other question that came in, which is how beneficial is it to have programs such as the drone one to knowing if the project is on schedule?
That's a good question. So the drone is very beneficial. Just we use it as a tool with the owner as well and with the design team, just to give them a picture of how the project is and at what stage, so they can see a clear picture, the 4K picture of the actual site. We update it every week, and it's helpful just like that, especially during this whole COVID crisis. The design team and the owner don't come out as much as they typically do.
Yeah, the pictures we get from the drones, they're really a great planning tool. We use those in our planning meetings to coordinate work and review with our subcontractors. Our superintendents really use the drone photos quite a bit.
Okay,
So-
we've answered all the questions.
Yeah, so thank you. I know we went a little bit long, but thank you everybody for participating. I hope everybody learned a little bit today, and we really had a great time doing this. So thank you, Paulette.
Guys, thank you so much for putting this together. This was awesome. And thanks for getting that tower crane takedown in there. I've always wanted to see that. So pretty excited about all those videos. So thank you again. We really appreciated it. And great answer on all the questions.
Great.
Awesome.
Thank you, everybody.
Thank you, everybody.
Thank you.